So my name is Orel Zion. I'm a senior mobile developer at viz.ai, which is a healthcare company. And I'm here to talk to you today about pagination. So pagination in general, pagination, yeah, we'll see. Cool. So let me start by a raise of hands. How many of you are in healthcare? Yeah. No one, right? Oh, just one. That's cool. But how many of you have dealt with pagination before? Like any kind of pagination? Yeah, most of you. Probably. Some of you have used Google's pagination library, version 3 or prior. Doesn't matter. Okay, you wrote your own custom implementation for pagination ever before? Yeah, right. Cool. Yeah, so I've done some research. I've searched Twitter for pagination. And here are some cool tweets that I found. So like, why is pagination so hard? This clever one, it's not pagination, that's agination. And again, about how hard it is. Moving on to search Android plus pagination. And I found this tweet. Our Android developers actually using pagination 3 library. And they actually get a lot of answers, a lot of tweets. Some people say that it doesn't have a single source of truth or that it's very confusing. Some people say that it's like good for the simple stuff, but for the more complex things, it actually becomes less good, I'd say. So filtering, mapping, any sort of these things become harder on this library. So some people suggest don't use a library, just write your own custom solution. And then there is this tweet that I really liked about how with XML it's a headache, but moving to Compose actually makes that a breeze. We're gonna see if that's true. So is pagination so hard? That's a question I want to ask. Yeah, it is. It is. I agree with you. But let's discuss this a little bit. So when I signed up for this talk for a month ago, not thinking that it actually get accepted, but what I had in mind is we had to deal with pagination at Viz. We had this new feature that we needed to implement, and we're rethinking about pagination solution. And I tried to find like a better way to handle it in our application. So I was looking at Google's pagination library, and I saw a lot of tutorials online, read some, watched some videos about it. And what I found is that they all have like this common thing that they all show you the most simplest use case possible. That's like load a bunch of photos from the internet and just like infinitely scroll them, which is not what you usually do, right? We usually like have search and filters and actions. We add in things to bookmark. We do a lot of things with our items in list, and they usually just show the simple use case. But moreover, using the pagination library for the simple use case, I think it's wrong, because it's like trying to cut your salad with a sword, so I think, right? It's like you have this very simple use case, but you're using this very complex library to solve that, and it's just gonna take you a lot of time and not gonna solve anything for you. I mean, it will, but with greater cost. But on the other hand, when we do have the complex use cases, we don't want to use something that is simple, clean, and wrong, right? We want to use something that is fit to our use case. So let's talk a little bit about our agenda for today. I'm going to be presenting a complex use case for pagination, the way that we did that at Viz. We're going to see some code of implementing this without any library, so this is my own custom implementation. We're going to see some code of using it with the library, and then we're going to discuss like how it helps us, how it reduces the amount of code that we need to write, how it actually helps us organize things, and some cons, of course. The world is not perfect, so we're going to discuss a little bit about its cons. Cool. So before I move on, just a little bit about Viz so we understand how the app works. So our mission at Viz is to help physicians get to the patients as quick as possible. We're trying to reduce like the amount of time passed between when the patient is entering the hospital and until he actually gets treated. So usually when a patient is entering a hospital, we send him to a CT scan in a case of stroke, for example. This is something that we have a lot of experience in. So the user sends to a CT scan. As soon as the scan completes, it gets uploaded to our servers where our AI algorithms, but this is the last time I'm going to say AI in this talk, don't worry. So our AI algorithms are examining it, trying to understand if there is any disease, if we can find anything in the scan. If we do, it sends a push notifications to every specialist that should get triggered. So they get this loud noise to their phones. They just open it. They can see the scan in the phone. They can interact with other team members, which is the most important part. They can interact with other team members and get to this patient as quick as possible. We are, on average, we are reducing the amount of time passed between the CT scan and the actual treatment by an hour and a half, which is a lot in terms of stroke. It's just literally the difference between a person that could go healthy in a week or a person that needs to stay in the hospital with a disease. It's really amazing. So that's a little bit about Viz, and this is the actual app. This is how it looks like. It's a screenshot from our app. So you see that we have different tabs. You see the pagination here, as you saw the item, the loading item there. We have different tabs, which I refer to as different filters. So we have the all cases for all the different cases, some specific cases. We're not going to go in details into that. And saved cases, which is kind of like a bookmark. Also, you see that we have a search, right? So we can search for a specific patient on the app. And most recently, we also added in-tab filtering. So you can just filter a specific tab. And I'm saying most recently because that was literally last week. All right, so last week we added in-tab filtering, and it took me a day to add this extra functionality, and I think this proves that the system works. The pagination is working for us. So let's discuss a little bit about the complexity of what we've just seen. I'm going to give you another example from a different field. So the kids just got back to school this week, right? So I needed to buy some stationery for them, and I went to an online shopping app just to find things. And you know how usually, and think of your favorite shopping app, no judging, and you usually have the different categories, right? And you have the recommended for you section, and you have search, and you can add specific items to your wish list where you will have this small icon, right? A heart icon sometimes. So you have different categories, but you have shared items between those categories. So the same item can be in different lists. And when you add an item to your wish list, you wish to see this little icon synced across those lists, right? So you move between one list to another, you see the same item, you should still see this favorite icon or on this item. So usually what they do is that they just reload the list from the server. So you move between one tab to the other, you just reload everything. This is not an acceptable solution for us because we deal with physicians. We said that time is very, very important. We actually have a saying, we say time is brain. So we have all the items that we downloaded saved in cache, so we save in a room database. So that means that all of the items are actually saved locally, and when we move between tabs, we just need to fetch them from the DB first because we want to be as fast as possible. But we still need to think about how to sync those changes between all of these items that are shared between all of these lists and save the pagination state. So when you move to the other tab, you should continue with the pagination from where you were and not reload everything from the beginning. So there's a lot of complexity to that, and we're going to see how we solve that. Cool, so our assumptions when we moved, that's basically what I said. We have different lists, right? We have shared items, we want to sync between them, fast switch, and save in the state. Cool, all right. So a brief overview before we move on to the actual code session. So this is a basic infrastructure of my custom implementation, right? So this is not, without the pagination library, this is like what I did in a custom thing. So on the UI part, I have the paging adapter, so I wrote my own abstract class with paging adapter, so that is for the item loading. So when you like load new pages, you should see like this loading indicator on the bottom, right? So this is something that handles this, and we have the scroll listener. So whenever the user scrolls, we actually observe this scroll, and when it reaches the bottom, I have a callback that says, all right, we need to load like new items. Now, this one is really important. So whenever we switch between tabs, right? So on tab selected, we actually have, I save the filter to my view model. So each tab gets assigned a filter. I don't treat it as a tab. For me, it's filters. So that's the same thing for tabs, for search, for the in-tab filter that we saw earlier. Each one gets its own filter with its filter ID. So whenever we switch in between tabs, we're like changing the filter, then we go to a repository and like try to fetch the items for this specific filter ID. So that means that we save the items to our database with this filter ID. We fetch them from the remote with this filter ID. And everything is done with this filter, so that is how we can like move between different filters and like fetch everything from our local database, because we have a specific filter ID for each one. Another thing that we see in here is the paging properties DB. Well, what's this all about? So usually I think it's the most of the cases people using pagination with like page indexes, right? So you start with page index 1 and go like to 2, 3, and etc. The problem with using paging indexes is that if your list is very dynamic, so in every minute new patients come into the hospital, so we always have like new patients, using paging indexes actually means that the server and the app not always in sync. So if I think in the app that I'm actually on index 2 and I have this 10 patients in like page 2, that's not necessarily what's happening in the server. Server is stateless. So it like if it goes and try to understand, okay, so index 0 to 10, what are the patients that I need to return? It will probably return something different than what I have in my app. Instead of using page index, we're using a last cursor ID. It's a better method to deal with that. So I'm just sending the server, this is the last item that I have. I want 10 patients from there moving forward. So to use that, I'm actually having another table that has like the filter ID and the last patient ID for this filter. Also added there end of pagination. So if I like already reached the bottom of the list, I will not like just go to the server and waste network calls. So this is a brief overview, and now let's go to actual C decoding. Let me just make this a little bit bigger. Cool, is it? Yeah, it's kind of nice. All right, cool. But first, let me maybe run the app and see like the demo app that I have in here, and then we see the code. All right, so we basically have something that is very similar to what we saw earlier at the actual Viz app. We have the different tabs in here, right? It's fetching everything now from the remote. Now it's gonna go and like fetch new items. You see the loading indicator at the bottom there. I move to different tabs. It's gonna like load the items for this tab. I have refresh. I have the bookmark options, right? I have the bookmarks in here. That's basically the functionality. Now let's go and see some actual coding, if we may. Cross your fingers, I need to type. Cool, so first thing first, we have the patient adapter, which extends the paging adapter that we saw earlier, right? So the paging adapter is an abstract class. It has this is loading more function, so whenever we update that, it's actually loading some more items. We need to have all this in sync. We're saying, okay, so we need to add another item to the list. We update the item count. If it's loaded more, we update it to just one more than the actual list item. We're creating a new view holder for this loading item, right? And this is basically what we have in the paging adapter, and the patient adapter just extends it and provide the view holder for the actual patient item. So that's about the adapter. How do we update it? So we also have the scroll listener that we discussed. This is very basic stuff. Just whenever we scroll and get to the bottom, we actually, and we're not already loading, so we call in the load more items method, which we implement back in our fragment. So whenever we call the load more items, we just call the load more function in the view model. All right. The other thing that we saw in the UI category is the tab selection, right? So whenever we select a new tab, we actually go and change the filter ID, and then we go to fetch the patients for this selected tab, for this filter ID. So we see in here that we go into our repository, we're fetching the list for this filter ID, right? Now let me discuss a little bit about what we see here with the coroutines, okay? So you see that I'm saving the job that I'm working on, and then I'm like, before every job that I launch, I'm canceling the previous job. Why is it important to do that? Because we have pagination, right? So whenever we like scroll, we can launch like new jobs to fetch like new pages. But think, for example, that we scroll, we trying to get more items to this page, and then we like move to the other tab. So now we need to fetch like a whole different items. And in race condition, what can happen is that we fetch the items for our tab first, and only later we like receive the items for the previous tab, and then it will just go and mess with everything that we have. It will just show us the items from the other tab. So that's why it's really important to cancel the current job before we actually start in the new job. So this is another thing to think about. Also like handling this one, right? So if it's not active anymore, don't do anything. That's part of the canceling part. Cool. So that's in the view model. Moving on. All right. So we go to a repository and we're trying to fetch a new list, or to fetch like new items for the same list. This is for refresh. So whenever we like refreshing, so we delete everything from the database. All right, so this is the paging data that we discussed earlier. So the paging data, I go and like try to fetch paging data for this filter. So if I have any, that means that we already have some pages for this filter. If not, this is probably a refresh situation, or that, sorry, my word dropped, not in a good way. Okay, so if it has already reached its limit, I'm just like returning whatever I have in the database and don't like fetch anything else. But if not, I go to my remote data source and like fetch the new items. I save it to the database. I'm saving the paging properties, and then I just return whatever I have in the database for this filter. So this is the basic approach for like updating everything in this custom implementation that I have. I then update the UI in here. This is back in our fragment. So error state, right? Updating the list. So we updating the adapter in here. We have the new patient list. We updating the adapter with it. We update the is loading more state. So if it's loading more, we need to tell the adapter that it's loading more. So it will show this item indicator on the bottom. Yeah, and like updating the refresh state and et cetera, et cetera. That's the custom implementation. Now let's move on to how this actually looks like when we're using Google's pagination library. So this is a diagram that I took from Google's site, all right? So this is how they show it, and this is how it actually works in my code. So on the UI part, we have their own paging data adapter. So this is not a custom adapter anymore. This is their own adapter. They are responsible for listening to the scrolling state and do all this, and they're responsible to actually go and fetch new data, and we're gonna see like how we have in a flow of paging data. So we listen to this flow from a view model and updating the adapter accordingly. We're gonna see that in a minute. And we have something that's called a pager. So this is something that we define in our view model. We're going to see like how and why is that important. But the pager is the one that is actually responsible for fetching new data, either from the database, that is the paging source that we see here, or the remote mediator that is equivalent to the remote data source that I had. And the way to do that, and the way that it will work with our complex use case, is that we creating a new pager every time we are moving between filters. So whenever we like move between tabs, in this example, we are creating a new filter. That means that we need to create a new pager. This is okay, it doesn't cost us anything because everything is saved on the database. Creating a new pager doesn't actually create anything aside from like refetching everything, like reselecting which filter we should now be looking at. All right, so let's gonna see that. I need to exit the presentation mode so sorry. So I can go to a different branch. Cool. We did that. All right, great. So gonna see that. So first, we have in the paging adapter. We are now no longer extending my own custom paging adapter. We're now extending the paging data adapter from the library. We need to pass in the data item that we work with and the view holder as we used to. That's all for the adapter. And the way that we update this adapter is that in our view model, we now exposing this patient list flow. So this is a flow that is emitting a paging data, right? And a paging data is this object that also have this item inside. And instead of submitting the list, right? Usually we go to the adapter and submit the list. We're now submitting a paging data. And this is how it works with the library. But how to create that? So instead of like saving the filter ID like I did before, I now have a filter flow for that. I have a filter flow, it's a mutable state flow, and this filter flow gets updated whenever we move between tabs. Having that actually helps me to have a flat map on this filter flow to attach the actual pager flow. So the fragment is listening to this flow, right? Patient list flow, and it has no idea that it's actually not the same flow. We keep changing the flow whenever we changing the filter flow. That's the idea in here. So we like creating a new pager whenever we like change the flow. The fragment has no idea. It shouldn't have any idea. It just wants to get the flow. That's it. All right. So moving to the pager. So the pager consists of several things, but let's see first the config. So this is much more sophisticated than the implementation that we saw before. So before what we saw is that I have the scroll listener that just whenever the user scrolls to the bottom, we are loading new items. In here, I can actually be more sophisticated. I can set the page size, of course, but I can also set the initial load size. So maybe we want to load like the first load to be more than just one page. That could be a use case for some people. Also the prefetch. So this is, we're not like loading whenever we reach the bottom, we are loading a little bit before that. We can like set whenever we want to load. So in this case, I'm just like half of the page. So whenever the user reaches half of the page, if we have like 10 items, that should be like index 5. We're already starting to fetch the new page. This is it's much better for the user, right? So the user usually doesn't even see the loading indicator. It just sees like new items keep coming to him. And I actually needed to add like a delay of 3 seconds. So in my demo for you, you will see the loading indicator because usually it just like comes in, you don't even see it. Cool, so that's that. Moving back in here, so we understand. So we saw like our flow of paging data. We saw the pager, like how we create it. But we need to also pass the paging source and remote mediator to the pager, right? So we do that in here. So this is the paging source. It's actually a room database. Let's see how we do that. What's the index now? 6, right? Yeah, cool. So yeah, in a room database, instead of just having like this type of thing which returns a list, we can actually have the same thing but returning a paging source, right? So returning a paging source with a key and a value. I don't actually use the key, so ignore that, but the value is the page identity. That's that item that we are returning. Some people might use the key in here, so if you're based on a page index, then you maybe won't use the page key, but as we said, we don't use the page index, so we ignore the key. All right, so that's the paging, sorry, let's go back. And the remote mediator, yeah, so we define the remote mediator in here. That's for whenever we need to like go to the server and like fetch new items from there. Cool, I'm using an injection in here, doesn't matter, but this is like the remote mediator. Cool, so the remote mediator actually have two methods that we need to implement. That's the initialize method and the load method. What's the initialize one? So the initialize is how should we treat creating a new pager? Okay, so if we create a new pager, what should we do? Does creating a new pager mean that we are refreshing the list? Or not. So in this case, what I'm saying is if I have anything in the database, right, so just skip initial refresh, get me everything that I already have. But if not, then yeah, you should like refresh and go to immediately to fetch things from the server. So that's the initialize method. The load method returns a mediator results. This is where we actually load things from the remote, from the server. Mediator result can either be a success or an error. Sometimes things fail, you know. And we receive two parameters. We receive a load type and a state. So load type can be either a refresh. That's like when the user refreshes the list, or maybe the first load. First load and refresh are basically the same thing. We have what we call a prepend, which I don't use, which is like if you want to like scroll like back in time, you want to scroll like up, not down. I don't use it, but if you do, so you have it. And the append, which is like to append the list, right? To fetch like new pages or something like this. And what I do in here, so remember I had the paging properties table, right? So I like go and see if I have a last patient ID for this filter ID. Don't need that anymore. I'm having a state, which I received in here. It's a parameter that I receive from the paging library. And I can just go and ask the state, do I have a last item? If I have a last item, I want to take the ID from there. If not, so I'm just like returning, okay, so this is a success, but like keep trying, like eventually, if the user like try to keep scrolling, let's let him do that. All right, so this is how I configure the last cursor ID. This is last patient ID, basically for us. And then we go and like call this load more method, which is just my method. I just go in here and I call the remote for the specific filter that I need. Either it's the bookmarks or a specific type that I'm loading from there. And you see that I pass the last cursor ID immediately from the paging library. I don't need to use any database for that. If I don't have the last cursor ID, it means that it's probably a refresh, or so I like delete all the previous records from the database. And if it's a success, I'm just like creating everything and save it to the database. So the database is actually the single source of truth. This is where the pager is gonna get all the items from. So I'm just saving it and returning reached, and this is basically just a value class, right? It's a Boolean. So I'm returning whether or not we should like keep fetch new pages or not. So if I like receive less items than the page size, then it's probably like the end of pagination. So that's it for the remote mediator. This is like basically everything that we have in the repository. And the view model. And like the last thing that I want to show you guys is, I think it's 11, right? Yeah, okay, so the last thing that I want to show you is how to actually watch the loading state. So we might need that for analytics purposes. We need that to update maybe empty states. This is like how I use it. So you actually need to go to the adapter. So you go to your adapter, and then you have a load state flow. and you collect it from there, and you update everything. So you update the load state when it's a refresh load state. So like I'm updating this loading indicator for the refresh state or the empty state, etc., etc. This is how I do it. So basically what we saw in here is that I got rid of my custom implementation of the adapter. I got rid of my custom implementation of the scroll listener. I even got rid of my table for the paging properties. All of that is handled by the pagination library, and I don't need it anymore. That saves me like a lot of time. Oh, just one more thing. You're probably wondering how to do that same thing with compose, right? Right? Let's gonna do that. Yeah, so it's a lot better. Back to presentation mode, and cool. All right, so I have this compose activity that I wrote in here. It's a simple surface, right? So this is kind of like a screen. I don't know like how to define it. I have a column which is kind of like a linear layout with a vertical orientation with the tabs and the patient list view. So the tabs are still doing the same thing, right? So whenever we click on a tab, I'm going to the view model and like updating the tab selected, which updates the filter flow, right? Same thing. On the patient list view, I actually have a lazy column. So lazy column is basically like a recycler view, okay? It's just that we don't need an adapter anymore. Yeah, it's huge. Using an adapter is one of the things that always like gets me. Like I need to do the recycler view and create the adapter, creating the view holder, and this is like so much easier. I just have the lazy column in here and the items property, which I just inject the items inside. But how do I connect that with everything that we saw earlier? How do I connect that with the paging items? We saw earlier that we need to go to a view model, listen to the flow, and add the paging data to the adapter, right? We don't do that anymore. We have the items in here. So these patient items, what is this? It's actually very simple. It's the same flow that we saw before. We're just adding this neat method, collect as lazy paging items. It's something that they added for Compose. And that's basically it. I'm just like passing it to the items properties, and I have all the paging capabilities like already built in. I didn't need to change anything in a view model, didn't need to change anything in the repository. I only like changed the things in the UI, moved from the XML to Compose, and this is basically it. And this is kind of like a view holder, right? So I have my view in here. It's a composable function, which with the actual like item view, which I define inside of the items block. To observe the load state, I do the same. I take the patient items, I observe this load state flow, and I update the loading state, error, etc., like we saw before. Let's see how this works. All right, so this is now the same app, just built with Compose. You see that we still have our loading indicator down there. We still have the bookmarks capability. We also have like the refresh capability. So everything that we saw earlier is still kept. We're just using Compose. And the fact that I didn't need to change anything on the view model or the repository, I think it proves that the separation of concern in here is very good, because the UI changed, not the logic of the UI, but the actual, like the UI library that we use. We changed from XML to Compose, and we didn't need to change anything on our view model or on our repository, so that's great. So to wrap up, sorry, my water again. So we saw that using the pagination library actually make us write less code. It's less work, it's more organized, it's more sophisticated, because we can do things that we couldn't do before. We have the prefetch distance and all those sorts of things. Less code is always, okay, maybe not always, but most of the time less code is better, because bugs are coming from your code, so less code, so probably less bugs. All right. Some cons that when we use the XML, it did seem like we are mixing view and view modeling here, because whenever we wanted to listen to the load state, we needed to go to the adapter. So we went to the adapter.loadState, which isn't that the best thing, because you usually think of an adapter as the viewer, right? And we say, all right, why do we listen to the load state from the adapter? That actually doesn't make a lot of sense. But moving to compose, it's not a con anymore. It seems like it's very, it's actually making a lot more sense, as we saw, because we didn't need to change anything in a view model, we just worked. Another con that I see is that the paging source actually requires us to define a paging key. I mentioned that before. I don't use a paging key, and it still requires us to define that in the paging source and the pager. Probably, I don't know, like maybe they have a way to just remove that, but this is basically it. So thank you all. It's going to be some question time. I have my GitHub in here. I'm going to upload the code there. Also created a new Twitter account only for dev things. So if you want to follow, please do. Thank you.